My name is Narendra. I am from Mechanical Department. Today my topic is direct and indirect bandgap semiconductor. Direct and indirect bandgap semiconductor. Introduction to bandgap semiconductor. Bandgap semiconductor are classified based on the energy difference between their valence band and conduction band. The two main types of bandgap semiconductors are direct and indirect bandgap semiconductor. Understanding this classification is circular for application in electronics and electronics diagram. What is band gap? The band gap is the energy range in a solid where no electron states can exist. It determines the electrical conductivity and optical properties of the material. A large band gap typical results in a semiconductor that can operate at higher temperatures. Direct bandgap semiconductor. Indirect bandgap semiconductor, the maximum of the valence band and the minimum of conduct band occur at the same moment. This allows electrons to the direct transit between the band with the emission or absorption of a python materials like gallium is an example of direct bandgap semiconductor making ideal of light emitting devices. Characteristics of direct bandgap semiconductor. Direct bandgap semiconductor are efficient in light emission, making them suitable for LEDs and laser diodes that exhibit high absorption coefficients, allowing them to absorb light efficiently over a range of wavelengths. These materials are often used in photovoltaic cells due to their ability to convert light into a electric efficiency. Indirect bandgap semiconductor. Indirect bandgap semiconductor have their valence band maximum and conductance band minimum at different moments. This means that an electron transition requires a python to convert moment, making light emission less efficient. Silicon is as well known example of an indirect bandgap semiconductor widely used in electronics. Characteristics of indirect bandgap semiconductor. Indirect bandgap semiconductor typically have lower efficiency in light emission compared to direct bandgap semiconductor. There are, however, excellent for applications involving electronic devices such as a transistor and diodes. The phenomena assistant transistor in the materials can lead to longer lifetimes for excited states. Comprehension of direct and indirect bandgap semiconductor. Direct bandgap semiconductor are better for electronic application, while indirect ones still in electronics application. Efficiency of light emission is significantly higher in direct bandgap semiconductor. Indirect bandgap material can be more abundant and coefficient such as silicon in the semiconductor industry. Application of direct bandgap semiconductor. Direct bandgap semiconductor are widely used in LEDs, lasers, diodes and protectors. They are circular for techno communications where light source needed to be efficient and reliable. The use of direct bandgap materials in solar cells has led to advance in renewable energy technologies. Applications of energy bandgap semiconductor. Indirect bandgap semiconductor are primarily utilized in the fabrication of integrated circuits and microprocessors. Silicon as an indirect bandgap materials from the backbone of modern electronics. Researching is ongoing to enhance the light emission properties of these materials for potential optoelectronic applications. Conclusion. The understanding of direct and indirect bandgap semiconductor is essential for advancement of technology. Each type of its unique properties and applications that cater for specific needs in electronics and optoelectronics. Ongoing research continue to explore new material and methods to optimize their performance in various applications. Reference Size SM and NG 2007 Physics of Semiconductor Devices Wiley X and Y 2016 Bandgap Engineering of Two-Dimensional Material Journal of Physics Concerned Matter LG and LES Semiconductor Optoelectronics a key technology for the 21st century of Stinger. Thank you.